Okay, so there are three big theorems you need to go through for calculus. EVT is one of them. So EVT is the extreme value theorem. And so keywords you're looking for are absolute, global, and then on an interval. So if you in a problem see something like an absolute maximum or a global maximum or a maximum on an interval, you really need to be thinking EVT. So with EVT, it's kind of like the first derivative test with kind of like a little twist to it. You still need to find critical numbers. And remember, critical numbers are where f prime is equal to 0 or where f prime is undefined. What you need to do, though, is make sure they fall in the interval. If there's any that are outside the interval, you do not include those. You want to also include endpoints. And so once you include your critical numbers in the interval and your endpoints, you plug values into the function and find the literal max and min. So it's just like the first derivative test. You set your first derivative equal to 0, you solve for your critical numbers. But once you do that part of it, you've got to make sure you're looking just on that specific interval. So for this function, we want to find absolute maxes and mins on this interval. So first thing we're going to do is find the derivative. So that's going to give us negative 3x squared minus 12x minus 9. So we're going to set that equal to 0. Now, first thing I see is they all have a negative 3 in common, so take that out. And then that is something that's a little more pleasant to factor. So the only things that multiply to make 3 are 3 and 1. Since that's positive and this is positive, that means these both have to be positive. So our critical numbers are negative 3 and negative 1. So now we look. Is negative 3 in that interval? Yes. Is negative 1 in that interval? Yes. So once you've done that, you need to make sure you include your critical numbers and your endpoints in your test. So I usually will make a table here of like x and then y. So I need to include my endpoints, which are negative 3 and 0. And then my critical numbers are negative 3, which is already in there, and negative 1. Now, once you get that, you literally are plugging these into the function itself. You're not plugging them into the first derivative. This is an x, y table. You want to find the actual maximum and minimum value. So you need the function value, not the derivative value. So as we plug all those values in, you're going to take negative 3, negative 1, and 0 and plug them all in place of x up here in this function. Just to save time, I've got them all plugged in already. Negative 3 comes out to 3. Negative 1 comes out to 7, and then 0 comes out to 3. So we are looking for the absolute maximum and the absolute minimum. So the absolute maximum is literally the biggest value. So the biggest value right here is 7. So this is the absolute max. These values are the same. So these are both the absolute min. So you have to be careful about how the question's worded. If it asks you for the absolute maximum, it doesn't mean where does it happen. It means what is the absolute maximum. The absolute maximum is 7. If it asks you what is the absolute minimum is 3. If it asks you for the location for the max is at negative 1, and for the min, it's at negative 3 and at 0. So with EVT, you find your critical numbers. Are they in the interval? Include your endpoints, then plug them into the function.